Welcome to the R video tutorial on linear discriminant analysis in R. In this video tutorial, you'll learn how to use the LDA function to fit a linear discriminant analysis and also evaluate its performance using predictive performance and cross-validation predictive performance. Okay, for this you will need to load the library MASS, the MASS library, which may or may not load automatically in your session of R. And I'm going to read in a reagent data set. Okay, over here you can see we have a reagent data set. It has two reagents, reagent 1, reagent 2, and has groups A, B, and C. And what we want to do is we want to plot this data. That's our next statement. And we're going to plot columns 2 and 3 that omit the group so that we can see what the groups are. And we're going to have the color be the group. So this statement here will do this. It pulls columns 2 and 3, and the color is associated with the first column. Okay, so here we can see that there are clearly three groups. There's a group that's in black, a group that's in red, and a group that's in green. Notice the red and the black overlap each other, whereas the green doesn't seem to intermingle with either of the other colors. So we have three distinct groups here, and we want to find a linear discriminant analysis that will be able to tell, based off which reagent we have, which reagent combination we have, the group it should be in. Okay, so let's look at the code to do this. The code is incredibly simple, so I'm going to use the LDA function, and it's just for linear discriminant analysis. You put in the grouping as your dependent variable, put the tilde sign just as if you were doing a regression or ANOVA, and you put the two predictors. So we want to classify these two off of reagents. The only thing you need to remember here is that the dependent variable must be categories. They can't be numbers. They must be categories. And then here the data I'm using is data 1, which is what I read into. I'm writing this into data1.lda. And we can do this real quick and see what the output is. And if we look at this, you'll see that it gives you a bit of output here. It tells you the group means, it tells you coefficients of linear discriminants. You will learn what these are in your multivariate class or some other class where you learn these. And you also see prior probabilities of groups. So what proportion of the data seem to be in each group prior to starting. And these will help you define, the coefficients of linear discriminants will help you define the lines that actually discriminate between the two, because that's what linear discriminant analysis does. It places lines in and then use rules to tell you which side of the line which group is on. Okay, so let's see how well this performs in predictive. So I'm going to use the predict function. The predict function is a very generic function. It works on lots and lots of things. The thing you need to have is an object that predict can work on, which is our analysis, our LDA analysis that we fit earlier, and a data set. So here I'm going to use data 1, columns 2 and 3, and I want to pull off of here the class. It gives us a lot of predictions, but ultimately I want the class. And notice this $ class is outside of these parentheses. So if I run this, I can see that it doesn't produce much because I'm writing it into an object called data1.lda.p. And these are my classifications when I look at it. So it just gives me the classifications that are in the predictions. So this is what it determined they should be predicted to be. Now, one thing you might want to do is look and see how well it actually fits. So here you can use the table function, use your original data here, which are right here, data 1, comma 1, which is the column, the first column in our data set, and the predictives. And we can look and see how well this fits. And if we look here, data1.lda.p said it was going to be A, and the truth is that it was A 17 times, and that worked correctly. data1.lda.p said it was B 2 times when it was truly A. B was correctly classified 24 times. C was correctly classified 18 times. So that's, and notice these are misclassifications. Anything on the off diagonal is a misclassification. But that's how it fit and predicted its own data back. So what we'd want to do is we want to see how well it works with leave one out cross-validation. And we can go back and just redo this analysis very easily by adding our LDA statement. We can add the CV equals true, and it's going to do leave one out cross-validation. So it's going to leave the data point out, fit on the rest of the data, and then try to predict that data point back and see how well it does that. And then we can run a table on this just by looking at the classes that it came up with. And if we run this, you can see that in the leave one out, the cross-validation, it performs a little bit worse. Notice the off diagonals are the misclassifications. So in the off diagonals, you can see it misclassifies A and B a little bit more. So is this model bad? Well, that's totally up to your misclassification rate that's acceptable to you, but it's not misclassifying very much, and it correctly classifies C all of the time. But A and B, it gets mixed up a little bit about 2 times on 2 observations. All right, so this has been the R video tutorial on linear discriminant analysis in R. If you have any questions, please ask or watch the next video.